All right, so we're going to start our lesson off today with knowing how to find missing sides using trigonometry. This is a connection to what we've already done, our SOHCAHTOA that we learned in our last lesson. But now we're applying it, okay? So, I want to find the value of x. Do you see where it is? Step number 1, as you're listening. I need you to circle the angle that's given, not the 90, but whatever the acute angle is that's given. Can you circle it? 11 is what relationship to 32 degrees? 11 is what relationship? Opposite. What's x? Hypotenuse. Now, what I need to know, and you will know by memory soon enough, is what trig ratio, and for these questions, we're only going to use the primary trig ratios, meaning I'm not going to use the reciprocal cosecant, secant, and cotant, just the 3 primary, like the primary colors. So which primary trig ratio uses opposite and hypotenuse? That's what you need to know. So some of you are going to go, I don't remember. So then put it on the top of your page. That isn't wrong to put it up there. So which one uses opposite and hypotenuse without guessing? So what we're going to write down is, sine, because that's what that says. SIN is sine in trigonometry. Then I need an angle. You never write a trig name without an angle. What angle goes with sine? Theta. No, there's no theta. What angle? I circled it. So sine, we actually know the angle for these, right? We write down theta when we don't know the angle, but we know it. Sine 32 is equal to, draw a fraction line. What goes in the numerator? The opposite side. What goes in the denominator? X. So first up, can you set it up using the correct trig ratio? You can't use whichever one you want. You got to use the one based on what's given, yes? And can you set it up? Here's step 2. Can you get x by itself? Like, can you do the algebra to get x by itself? You ready? So, the inverse of dividing is to do what? Are you talking to me? The inverse of dividing is to multiply. So I'm going to multiply both sides by x. X is still not by itself. What do I still have to do to get x by itself? And the answer is divide. And I'm dividing by. So, step 2 is, can you get x by itself? Now, step 3. Do you know how to use your calculator? So, let's do it together. Now, how many have ever done this in their life with their calculator, doing trigonometry, right? So, it's better to be a good listener than a good talker right now. Is that right? So, step 1, with your calculator. I need you to look at the bottom bar of your screen. I want you to notice that my calculator is in degrees. It's in degrees because it says DEG on the bottom. Do you see that? Some of you have 3 other letters on your screen. Do you know what you see? R-A-D, right? Rad, which means it's bragging about itself about how cool it is. No, it is. Like that? Huh? No. So, if it says R-A-D, we need to change it to degrees. And the reason is, the angle here is given in what unit? Degrees or radians. So our calculator needs to be in degrees. Listening? Hey, I need to have the skill to go back and forth with my calculator. If it's in degrees, I know how to do it. If it was in radians, I know how to go back to that, no problem. Ready? So I need you to press the mode button. It's here underneath alpha. Can you do that? And then go down like 3 or 4 steps. Do you see radian there? Okay, press the arrow, right arrow, and now do you see degree? Highlight it. So highlight degree, press enter twice. Now look at the bottom of your screen. Do you now see degree? Or you can use your iPhone if you want. But it's more complicated. How to type it in is weirder on your iPhone. But if you get the calculator and turn it sideways, it is a scientific calculator. Sideways? Yeah, sideways. Sideways. Yeah. But how I'm going to type it is going to be different than you, I think. Because here you type it all in, you press enter, there you got it. You'll figure it out. This is better. Okay, so are we all in degrees?
Yes.
Who's not in degrees? So you have your end spire, right? So you need to know how to go to your document settings. I wonder how you're going to do that. I mean, you're probably going to have to press document on the right. Then is there a thing that says settings? This is actually more complicated on the end spire than what ours. So that's just the one thing I find more clunky on the end spire is to change its mode. And then when you go to settings, there's a spot there that you can change it from radians and degrees. What happened? Radians, yes? What? Yes. Yes. There's actually a third one you could change it to, but we don't need that one. So it's radians or degrees. Alyssa, did we find it? Oh my goodness. Maybe it's menu. It's either document. I think it's document, settings, and then document settings. Yeah, that's what it is. So Inspire. Press document. Then you go to document settings, right? Do you see where it says, the second one down says angle. This screen right here. Cool. Press enter or OK. Does it say DEG in the top right corner yet? No, go back to your original. Document, DOC, then press settings, and then press document settings. So if you need to go back and change it to radians for a question, you can. Yes? Okay, we all together? You can fast forward this on your video, obviously. So here we go. This is the slowest question ever right now. Hey, I don't want to say your name. So here we go. Next, I need to type this in. So don't make it complicated. Since you haven't used trigonometry with your calculator before, I need to introduce where it is on your calculator. Yes? So with the TI-89, they are in blue. Now you might be confused because it also looks like it's in green, correct? But that little -1 is something different. I'm going to teach you. But trigonometry also has inverse function. Remember that's the symbol for inverse? We're not doing that right now. Got it? We will. But right now we just want the blue one. Do you see it? So what button do you press first to get the sign? Second and then Y or... Oh, turn my calculator back on. So I need to go 11 first though. So 11 divided by sine 32. You need to practice typing it in. If you don't close the parentheses, there'll be an error. So you got to close the parentheses. If you only press enter, you won't get the answer you're looking for. Go diamond enter. And approximately, how big is that side? And we're going to practice rounding to 3 decimal places, because that's what's expected on the AP exam. So let's do that. So the answer is 20.758. Okay, number 2. We are not going to go this slow ever again. So here we go. Can you circle the angle? Yep. Can you tell me what 21 is? Adjacent. Can you tell me what x is? Opposite. Which trig name uses opposite and adjacent? So you write down tangent of what angle? 75. What goes in the numerator? X, that's the opposite side. What goes in the denominator? And then, can you get x by itself? The inverse of dividing is 2. So we multiply both sides by 21, and now use your calculator. So I'm just going to type in 21 tangent 75, diamond enter. So again, 21, you don't even have to go times. So 21 tangent 75. And approximately, what's the size of that? Side is 78.373. All right, you try number 3. Can you set it up? Can you get x by itself? Can you use your calculator? Go. Number 3. And I will always support you. But try. If you do the first step wrong, the answer is wrong. So if you do not know which trig ratio, don't guess. It's because you know based on what's on the triangle. So it's adjacent and hypotenuse, so that is cosine of what angle? 23 degrees. And now the setup, it's adjacent over hypotenuse. The more you practice, the easier that'll be. Now get x by itself by multiplying by 30. And now use your calculator. So the answer is 27.615. Okay, try number 4. Let's go. Michael, the microphone picks up everything. Number 4. Circle the angle. 15. X. Think, which trig ratio must I use? Opposite and adjacent. So it's tangent 41. Opposite side is 15. The adjacent side is x. To get x by itself, you'd multiply and then you would divide. You are smart enough to do that in 2 steps. To multiply and then divide, to get that in 1 step. And then use your calculator. Keep going. 5 and 6. They're going to teach you how to find a missing angle using trigonometry. It'd be impossible to do this without trigonometry, what we're doing. So step 1 is to label your triangle to know, right? You're not guessing. Is it sine, cosine, or tangent? To get x by itself, you multiply and then you divide. So you can do that in your head, multiply and then divide. It's 3 divided by cosine 64. All right, last one like that. They're going to teach you to find a missing angle. Number 6. Listen, do you need my help? All right, let's do this. So number 6, know the trig ratio, know the setup, and so on.
Whenever I tried to do
it's still in radians, right?
yes. Is that in the documents it says it's in degree?
Well, where let's look. It says it's in radians.
Huh?
Just what you do. All right. Circle the angle. Opposite. Hypotenuse. This is what? Sine of what angle? 18. 25 over x. To get x by itself, you multiply and then you divide. So it's 25 divided by sine 18. And that's 80.902. Don't worry, you have homework and me practice with me, right, to get it even better. Let's look at the next step. Given trig value of an angle, use the corresponding inverse trig function to find the measure of the angle. So, we're going to set something up. If we set this up trigonometry-wise, to get the angle by itself, we have to use the inverse button. Remember the green button instead of the blue? That's true for all of these. If I want to get the angle by itself, I have to do the inverse and use that button to find the missing angle. So, the beginning part is going to be the same, and as you practice, it's actually going to be quicker to find a missing angle than the side. Ready? So let's start slow, and then you'll see how quick it is. So, in this example, theta is an angle we do not know. Question? Stretching. Here we go. 18 is the what side? Adjacent. 23 is the hypotenuse. And then, which trig ratio, and if you need to write this again, do it. Which trig ratio uses adjacent and hypotenuse? So the cosine of what angle? Theta, the one I don't know, is equal to 18 over 23. How do I get theta by itself? Is I use the inverse. So to get theta by itself, I do the inverse of cosine. That's how we solve an equation, is by doing the inverse. So what button do we press to find a missing angle? It's the green one, right? It's the inverse one. And those that have an N spire, do you know to press the trig button on the left? So that's the button you're looking for. It's in green. So you press diamond. Diamond. Yep, me too. And then it's 18 over 23. And then go diamond enter. So approximately how large is that angle? And the answer is 38.5. All right, let's try it again. Can you use trigonometry to find a missing angle? Here's the angle. What do I know about the triangle? I know the opposite side and I know the hypotenuse. Which one uses that? So the sine of theta is equal to 5 over 21. To get the angle by itself, we do the inverse. We are eventually going to be able to just get to this step. that if we know we're finding a missing angle, what symbol do we have to use? Inverse. We can get right to inverse, put in the ratio, calculator over, right? Know it's inverse, the ratio, done, right? One step. So, inverse sine 5 over 21. And again, you have to close the parentheses and go diamond enter. Oh. And you get 13.774. Recognize that you have to put a degree symbol on it, right? A little circle at the end. Turn the page. If your calculator's grumpy, just bring it to me and I'll look at it. Here we go. We're going to do this very quickly because you're smart and some of you are not focused and you're doing other things at your desk other than trigonometry. Here we go. So, when I look at theta, what I notice is opposite and adjacent. If you need to write this down on every page, you write that down on every page and don't you dare guess. Opposite and adjacent is tangent. To find the missing angle, we do inverse of that tangent. And then what goes inside is 17 over 18. Use your calculator. And the angle is 43.363 degrees. Again, number 10. I need you to know this is a quick skill in trigonometry. Once you know your trig definitions. I need to know what the size of theta is. Opposite and adjacent. Again, what am I going to use? And when you're finding a missing angle, go right to inverse. So if I want to know theta, it's the inverse of what ratio? 39 over 20. And that's 62.850. Try number 11 and 12. Let's do this. Can you put on the counter there for me? Thanks, Daisy. Hi, Jesus. So try number 11 and number 12. Again, opposite and hypotenuse. That would be which trig ratio? Not guessing. Sine. So inverse allows you to find the angle. If we're finding a missing side, we don't use inverse. If we're finding a missing angle, we do use inverse. Give her a nudge, because I don't want to say your name on the video. But I know that you're tired, and you don't have a calculator, and we're not practicing. You can even have your phone out. You can go on Desmos and do this, so that you're practicing, at least being, like, trying. And then bring your 89. Got it? Do you have a phone, a Chromebook? Anything? Good. Someone have a phone, Chromebook? Something. Borrow a Chromebook over there. Something's charging. Something. Here. So, inverse. Sine. 29 over 52. And you get 33.896 degrees. Okay, one more. Theta. How are we going to do it? And this is adjacent and hypotenuse. So what do we have to use for adjacent and hypotenuse? And what's the ratio inside? And the more you practice, the more you'll know your definitions. Inverse cosine. 12 over 19. And that's 50.833 degrees. Awesome. Okay, next thing I need to teach you is putting it all together. When you're asked to solve a triangle, what does that mean? So I'm going to teach you. when you're asked to solve a triangle, you have to find all parts that are missing. You can use the Pythagorean theorem and trigonometry, one, the both, whatever. Can you find all parts that are missing? Yay? Here we go. In number 13, how many parts are missing in this triangle that I don't know? 3, 2 sides and an. Yay. Do you know what's the easiest one to find first? That's right. And do you need trigonometry to find a missing angle? No. What you need to know is when you add all 3 angles in a triangle, it adds up to 180. But even better, when you add up the 2 acute angles in a right triangle, they always add up to 90. That's called complementary. So if I know 72, how do I find angle B? 90. Subtract 72. What's left over? I don't need trigonometry, just basic triangle stuff. And that answer is 18. Can you fill in the right part? Now, if I want to find side BC, I'm going to label that X. If I want to find side AB, I'm going to label that Y, and I'm going to use trigonometry to find those sides. So how do I find side X? So look, what's given? That's opposite and adjacent. Opposite and adjacent. Tangent 72 is equal to X over 15. How do I get X by itself? Multiply. So in your calculator, you're going 15 tangent 72. So 15 tangent 72. And on the side, I'm going to put that answer in, which is 46.165. Next, same question. How do I solve for y? What options do you have? Options? What do you mean options? What options do you have for y? Anyone know that you have options other than quitting? The Pythagorean theorem, because now you know. Or you could use trigonometry. This lesson's on trigonometry, so I'm going to keep using trigonometry. But if you wanted to do the Pythagorean theorem, you could. Yay? Now that you know 2 sides? Okay, so I want to solve for y. This time, it is adjacent and hypotenuse, which means which trig ratio do I need for y? Cosine. Adjacent is 15, and the hypotenuse is y. How do I get y by itself in one step? You multiply and then you divide. So it's 15 divided by cosine 72. 15 divided by cosine 72. Which is 48.541. All right, let's try number 14. What I want to do is solve the triangle. What does it mean to solve a triangle when you do, Alex? It means you have to find all the parts that are missing. That could be basic geometry, trigonometry, or Pythagorean theorem. All right, for number 14, what's the easiest thing to find that's missing? How do you find the missing angle? What's 90 take away 34? Brilliant. How am I going to find the other sides? I'm going to label one side X, and I'm going to label the other side Y. How do I find the length for X? Do I need trigonometry? Yes. How do I use trigonometry here? So, X is opposite. 42 is hypotenuse. So I have to use sine 34. And it's opposite over hypotenuse. How do I get X by itself? Multiply. And now use your calculator. So it's 34 sine 34. No. What is it? 42. There's no good reason to do that. 42. Ha. 42 sine 34. And then put the answer over there for RT. So 42 sine 34. So RT is 23.486. Now, can you set it up for Y? Y is going to be cosine 34. adjacent over hypotenuse. To get y by itself, I multiply. So it's almost the same setup, but using cosine. And it's 34.8, well, 20 if we round it properly. All right, try number 15. Solve the missing side before I go too quickly. All right, number 15. In this example, can I go 90 subtract to find the angles? No. So, if I want to find angle K in one step with trigonometry, I can do it. So, I need to know what sides these are. So for K, that's adjacent and hypotenuse. So if I want to find K, it's the inverse of which trig value ratio? And then it's 7.6 over 8. So inverse cosine, 7.6 over 8. So for angle K, that's 18.195 degrees. Do I need trigonometry to find L? No. Now, all I got to do is subtract 90, right? In fact, just type in subtract 90. And then what's the other missing angle if you subtract 90? 71.805. Again, what did I do? Is subtract 90, subtract that answer. And then you have a choice, don't you? If I label this X, how can you find that missing side? Just so you don't forget, if I use the Pythagorean theorem, what would that be? What would X equal? What do I start with? And then I'm going to, all right. And you get 2.498. All right, number 16. Solve that triangle. And then we're going to end the lesson with stories. You know, the ones that actually build buildings and roads and all this stuff, right, have to know their trigonometry or else we're all in trouble, right? All the homes flood. Everything goes away, right? If we don't know our angles, don't know our SOHCAHTOA, when there's an accident, right, and the police officer walks with their whatever, right, and measures it out, what are they doing? Trigonometry to understand the accident, right, and what's happening. The insurance guy that goes out there is using trigonometry to know who's responsible for the accident. Your math teacher is using trigonometry, right? To support his family. Here we go. Number 16. Can you find what's missing? Let's go. D. What would I do to find angle D? You're going to say, which one? Tangent of what over what for D? 22.5 over 21. All right. So angle D is 46.975 degrees. Make sure you put that little degree sign there. Quickly, how do I find F then? Subtract what? Subtract 90. So that means this is 43.025. So I just go 90, subtract that to get this. And then lastly, how do I quickly find that missing side? Again, we can use Pythagorean theorem. To find this would be the square root of 21 squared plus 22.5. So if I'm finding the hypotenuse, I add If I'm finding a leg, I have to subtract with the hypotenuse first. So the square root of 21 squared plus 22.5 squared. And you get 30.777. That's a good omen right there. 30.777, right? Turn the page when you're ready. All right, here we come. You ready? Here's some stories. So, the first stories have to do with something called angle of elevation. Have you heard those words before? I'm going to help you. Ready? If you are looking up at an object, what angle is it that you're looking up to the top? And it's the angle made with the horizontal in that angle looking up. So we need a horizontal. That's like a base. And then the other ray is looking up. And the angle there is called the angle of elevation. If you turn the page quick, you'll see the other one called the angle of depression, which is the one when you're looking down rather than looking up. Now, angle of depression is not like feeling sad. It's not an emotional state. Angle of depression just means you're looking down at something rather than looking up at something. Got it? So, when someone's looking up, it's called the angle of. When you're looking down in the angle made, it's called the angle of depression. All right, here we go. Number one, let's annotate it together. So, a fire started at a campsite located 8 miles from the base of a mountain. If the angle of elevation from the fire to the top of the mountain is 14 degrees, how high is the mountain? So we're going to draw this out. Here's my little campfire. Here's my mountain. And it says that, and we're going to make a right triangle out of this. So your fire to your mountain, we know the angle up to the mountain from the fire is 14 degrees. The base is 8 miles. So that means how tall is that mountain? So, step one, which trig ratio am I going to use to find the height? Tangent. So the tangent of what angle? And then x over 8. That's opposite over adjacent. To get x by itself, you multiply by 8, and then use your calculator. So 8 times tangent 14. So approximately how tall is the mountain? 1.995 miles tall. And if you want that in feet, it's like 5,000 something. And I always forget. You probably remember. I never grew up with miles and feet, believe it or not, because I grew up in another country. So I often forget the conversion rates in terms of that, because it's not obvious. And if you grew up with meters and kilometers, it's super obvious. But like how many feet are in a mile? 5,000. See, you don't remember. You grew up here. All right, here we go. That won't feel bad. Number 2. How many meters are in a kilometer? 1,000, right? Nice and easy, right? Like super duper easy. Good old metric system. 2. A man is standing 85 meters from the base of a tower. If the tower is 200 meters tall, find the angle of elevation from the ground where the man is standing to the top of the tower. I am going to draw a man. Hi, man. And I'm going to draw a tower. High tower. And from the ground to the top of the tower, and you might think it's silly, but when I'm not doing it for you, and you want to know how to set it up, step 1 is to sketch the problem. It's easy sketch, right? Unless you want to get all silly with it. But an easy sketch to be able to understand what's happening. What do I know about this picture? I know the tower is 200 meters tall. I know the man is standing 85 meters from the base. And then what am I asked to find? The angle of elevation. Next, you tell me what trig ratio I'm going to use, and then use it. Don't guess. opposite and adjacent. So that is inverse tangent. Again, when you find a missing angle, it's inverse. And what's the ratio inside the inverse? 200 over 85. Use your calculator. And you get 66.975 degrees. All right, number 3. I'm going to give you a chance to read, to annotate, to loosely sketch the problem, and then find the right triangle from the picture. Don't start with the right triangle. Don't start with the right triangle. You start with the picture. If it's a building and a ladder, you draw a building and a ladder. If it's a tree and a sun, you draw a tree and a sun. Go. Then the right triangle comes from the picture. All right, you can orientate it differently, right? Like if your wall is on the right side, that's fine. But if you made your wall on the right side, is it still the same setup? Did you label the ladder 32 feet, the wall is 18, and the angle is where the ladder and the ground meet? Now, which trig ratio do I use? Opposite and hypotenuse. And for a missing angle, you use the inverse. 18 over 32, use your calculator. Number 4. Yeah. I need you to read number 4. Annotate it. Sketch the situation. All right, did you do your best to draw it? Well, I'm going to draw it too. Now, you may not be as talented as me. It's okay. It's okay. Like that's tough. That's like going into the museum right there. Right? Like it might be tough to draw that. We know the kite is 60 feet above the ground, but then it says that she's holding it 5 feet above the ground. Is that right? Man, that takes some thinking to know what this side is right here then. So this whole distance here is 60. This distance is 5. What do you think I should label that side of the triangle with? 55. Is it 55? Great. What else do I know? Man, this looks weird. Does that look weird? Looks weird. So, I'm going to teach you something really quick about what you just saw. There are different ways to describe an angle. what this is describing is, instead of using a decimal, they're using time as a way to describe the decimal of an angle. Remember that an angle is part of a rotation, right? And when you look at a clock, it's just rotating, right? So that one tick mark, do you see a tick mark? 18 and a tick mark? That means 18 minutes. I know, isn't that crazy? So quickly, I'm going to teach you this. What decimal does 18 minutes make out of an hour? So 1 degree is equal to 1 hour. So 18 minutes is what decimal? So when you see it in minutes, all you have to do is divide by 60. But if I told you to divide by 60, you wouldn't know where it comes from. So how many minutes are there for one rotation? 60. But we don't have one rotation. We have how many? So if you go 18 divided by 60, it tells you what the decimal is after 48. 18 divided by 60. So what decimal would that be? 0.3. So this is going to be 48.3. I know, right? Why not just say 48.3? Say it. Why not just say 48.3? You know what? I agree with you. Some people like a different way to say something just to confuse you. But if you ever see that, and by the way, if you see 2 tick marks, that's now in seconds. So you could get an angle that says 20, and then it says like 18 minutes and 30 seconds. Isn't that crazy? Then, to understand this, you'd have to know that's 18.5 divided by 60, because 30 seconds is half a minute. All right. Moving on. I know. It's not, and I'm not going to give you that. But if you see it, there you go. So, we're going back here. I want to know the length of the kite. What am I going to do to find the length of the kite string? Which trig ratio? Angle, opposite, and what's this? Hypotenuse. What do you think opposite and hypotenuse? What am I going to use? So sine, you said sine, right? That's what I heard on the video. Sine, 48.3, and then the numerator, 55, the denominator, x. How do I get x by itself? Multiply and then divide, right? So ultimately in your calculator, you're going 55 divided by sine 48.3. And I get 73.664 feet. Did you get 73.664 feet? Okay, read number 5. This sounds real life again too. As someone's trying to construct a ramp, maybe make something accessible, right, to everybody so they can get into the room. So how do you design it and know what materials and so on to buy? So what do we know? A door ramp. Well, I can do that. That's just a triangle, right? A ramp. So what do we know about that ramp? So this is one situation where I just draw the ramp, which is a right triangle. We know the angle up is what angle? 8 degrees. What else do we know? From the ground to the top to the door, there's 1 point. And then we need to know how long the ramp should be. Yes? Okay, think. What trig ratio? Use it. Use your calculator. That would be opposite and hypotenuse. That would be, what is it again? Sine, thank you. 8 degrees is equal to 1.5 over x. To get x by itself, you multiply and divide, and then use your calculator. So 1.5 divided by sine 8. And the ramp would be about how long? 10.5 8 feet. All right, number 6. Sarah is standing 35 feet from the base of a rock wall, watching her 2 sons, Max and John, climb the wall. The angle of elevation is 38 degrees to Max and 27 degrees to John. How many feet above John is Max? So let's try to figure this out. So let's start with Sarah. And then there's a climbing wall. Do you know what a climbing wall is?
Yeah, like that, like the little.
It has like little knobs on it, and you go boom, 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 all the way up to the top, ring a bell, go all the way down, feel Spider-Man-like. So, you ready? So, I have Max on this wall, right? Who's taller? Who's up further up on the wall? The one that makes the bigger angle, right? So to Max, the angle is 38 degrees. But John is a little bit lower. That angle to John is 27. I need you to see 2 right triangles. Do you see 2 of them? One for Max and one for John. So what I'm going to do is, I'm going to just draw the triangle for Max. For Max, you'd use the angle 38 degrees. And it says she is 35 feet from the base, right? So this down here is 35 feet. So can you find how high Max is on the wall? Which trig ratio would you use? Opposite and adjacent. So it would be tangent 38 is equal to x over 35. So to get x by itself, you would multiply. So it's 35 and tangent 38. I'm going to let that go because I don't really care about x. I care about subtracting the 2 answers. So for John, what would the triangle look like? I'm going to call that y. This time the angle's not 38, but 27. Same exact setup. So to find y, the exact same setup, the only difference is the angle is not 38, the angle is 27. And then what do you do with the 2 answers? So in one step, type it in. So we're going to type in 35 tangent 38, close it, subtract 35 tangent 27, and then diamond enter. So how far apart are they? And the answer is 9.512 feet. All right, turn the page. Number 7. A building, or building A, is 464 feet tall. Building B is 321 feet tall. Dale is standing between the buildings. The angle of elevation from the point on the ground where Dale is 75 degrees to building A and 48 degrees to building B. So, how far apart are the buildings? Let's start. I need a building A. Here's my building A. Now, what do we know about building A? And Dale is standing in the middle. On the other side of Dale is building B. Building B is not quite as tall. So Dale's in between the two buildings. Feel it's depressing to have a building with no door, no windows, right? What we know is the angle to the top of building A, that angle is 75 degrees, and the building is 464 feet tall. If I go to the top of the other building, the angle is 48 degrees, and that building is 321 feet tall. And I want to know the distance from A to B. How will trigonometry find that distance between the buildings? So I'm going to label one X, I'm going to label the other one Y. I find the length of both, and then what do I do at the end? Add them, and there you have your answer. How do I find X? Which trig ratio will I use? Tangent. So the tangent of 75 is equal to 464 over X. To get X by itself, multiply and then divide. So it's 464 divided by tangent 75. The other triangle's the same setup. What's the only difference with the other one? The height of the building is 321, and the angle is 48. And then what do I do with the two answers? Add them up. So what's the distance between them if you add up those two? 413.358. All right, here's the last part of the lesson. Angle of depression is when you look down at something. From the top of a lighthouse, 150 feet above sea level, the angle of depression to a boat is 28 degrees. What is the horizontal distance from the boat to the base of the lighthouse? So I need a lighthouse. I need a boat. What I know is from the top of the lighthouse, 150 feet. So this height here is 150 feet. The angle to the boat, looking down at it. Now here's where you'll make a mistake. The angle of depression is not the angle inside the triangle. Instead, the angle of depression is the angle made with a horizontal line. So what I need to do from the lighthouse is I need to draw a broken horizontal line so you understand where that angle is. So from a horizontal line going down, the angle is what? So for angle of depression, is it inside the triangle? No, but it will be now. Do you forget your transversal and parallel lines and the whole bit? That makes a Z pattern. Ever done that in your life? Do you know that the water and the horizontal line are parallel? Yes? And this angle 28 degrees is the same as that angle 28 degrees because we have two parallel lines cut by a transversal and makes a Z pattern. So you could also do this. If you don't like that, you know what else you could do? What's 90 take away 28? 60. So you could also just say that's 62 by subtracting 90 instead of doing the Z pattern. Both are the same, right? Because 62 makes us 28. I want to know this distance from the lighthouse to the boat. What trig ratio? And I'm going to use 28. So opposite and adjacent. or I can use 62. But if I use tangent 28, it would be 150 over x, and to get x by itself, you just divide. So it'd be 150 divided by tangent 28, and then use your calculator. And you get 282.109 feet. That's how far the boat is from the lighthouse. Number 9. The angle of depression from a helicopter, oh, that makes me sad, to a landing pad is 34 degrees, 50 minutes, 54 minutes, and 8 seconds. If the horizontal distance from the helicopter to the pad is 1,200 feet, find the altitude of the helicopter. Altitude means height. That's my helicopter. I know. I'm sorry. So if you could draw a better helicopter, you should. So the horizontal distance from the helicopter to the landing pad is 1,200 feet. This is the landing pad. And it says the angle of depression to it. So when I make my right triangle, the angle is not inside the triangle. Now, I'm just going to help you with this. 54 minutes and 8 seconds. 54 minutes and 8 seconds is like 54 divided by 60. 8 seconds would also be that, but we'd have to then put that decimal at the end. So 54 divided by 60 makes it a decimal. That's 0.9. And this is really 54 and 8/60ths over 60. So what we could also do is, we could put it all in seconds. 54 times 60 is how many seconds? 3,240 plus the 8 seconds, and then divided. Do you know how many seconds there are in an hour? I know someone knows that.
That's 60 times 60, which is 3,000 or something.
Right, like that?
Let's go.
All right, so the angle here is 34.902. What would happen if you subtracted 90? Let's just do that. Subtract 90, what's the angle inside the triangle? And you get 55.098. If I want to find this, find the altitude of the helicopter. That's this side, going directly up. Start with the angle. That's adjacent and opposite. That's tangent. So the tangent of 55.098, or 092, or 902, that's what it says. It is 902. Tangent 55.902 is equal to opposite over adjacent. To get x by itself, you would multiply and then divide. It would be 1,200 divided by tangent 55.902. And that's 812. $812.4. All right, last one. Number 10. Henry is sitting in a tree 32 feet above the ground, watching a deer. The deer is 57 feet from the base of the tree. Find the angle of depression from Henry to the deer. You just wait. He's up here somewhere. I don't think it's hunting. It's Henry, not Hunter. And he's just looking at a deer. You can look at a deer without killing it. So Henry is sitting at a tree 32 feet above the ground. Oh, up here, 32 feet. The deer is 57 feet from the base. So we have 32, 57. What angle am I trying to find? The angle of depression. Is that inside the triangle? No. So, hey, I'm going to do another Greek letter for fun. I want to know theta, but that's not in my triangle, right? So instead, I'm going to find alpha. Alpha is inside my triangle, and when I know alpha, I just subtract 90 to find theta. So how do I find alpha? Is using tangent. So alpha is like a little fishy. Inverse tangent, opposite over adjacent. So start there. So inverse tangent, 57 over 32. Now, whatever answer you get, which is 60.69, you have to subtract 90. So if you subtract 90 from it, what's the angle of depression? So theta then is 29 point. So is the angle inside the triangle angle of depression? So we find that angle and then subtract 90 to find the angle I'm looking for because they're complementary. I know, remember those, right? Complementary? Hey, angle, pretty good today. Yep, you too. They're complementary. All right, Mr. G Math, over out.